Okay, now look at example 5. It's the last example with transformations. We're going to graph translations of the reciprocal function. So don't worry about other transformations. We are just going to look at translations. No reflection, no rotation, um, yeah, no other transformations. If you remember from the transformation lesson, you had a translation that could be seen by your parent function. Comparing with your parent function, you can see if it's a vertical translation up or down, or horizontal translation left or right, depending on your addition and subtraction and what your value is. So remember that for your vertical translation, it will affect your whole graph. So your f of x. So let me write g of x. Your g of x compared to f of x, because your parent function for a reciprocal function is 1 over x, your translation for vertical, your vertical translation k will be defined as plus k for the whole thing. So 1 over x and then plus k. And when k is positive, you go up. K is negative, you go down. But for the horizontal translation, to remember how horizontal was different. Yeah, it affects your domain, not your entire function. So your x must be solved first, which means you will have a partial modification. So you will have a parentheses, and then most likely, if you don't have parentheses, that's still fine because you have a fraction here, right? And then you will see minus h here. Why is it negative? Because your equation is written in terms of g of x, your range. So everything that's horizontal movement will be reciprocated. So it's the opposite. X minus h will be your positive movement. So when h is positive, you'll see x minus something, and that means you're going to have the graph translated to your right. When h is negative, you'll see x plus number. Then you'll find that when h is negative, oh, I have an addition, but h is negative. So then you have a horizontal translation to the left. Okay, so remember this. Horizontal translation is different. Okay. So looking at g of x here, we notice that from the parent function 1 over x, we have negative 3 and positive 2. We have plus 2 and k is positive 2. We have minus 3, which means h is positive 3. So do not confuse the negatives and positive here. You will be very confused when you look at it with addition and subtraction, because your h and k will be different. They have different rules. So if you just look at addition and subtraction, it'll confuse you a lot. So please make into a habit of differentiating h and k, because h will be subtracted from x and k would be added from your whole equation. Okay, so here h is equal to 3 and k is equal to 2. So that means vertical translation up 2 units, and then horizontal translation right 3 units. So yeah, as we have talked here, 3 units right, 2 units up. So shifting your graph, your parent function, you already know how to graph your parent function. Shifting your parent function up 2 units, and then 3 units right. So your asymptotes and everything moves up 2 units and 3 units right. So then you'll have a graph something like this. It's exactly the same. You're just moving your asymptote and all your entire graph 3 units to the right and 2 units up exactly. Okay. All right, so yeah, we used to have 1 comma 1 here, and then -1 comma -1, and then we had a graph like this, right? So instead of 1 comma 1, now we have 4 comma 3, but our origin also moved from 0 comma 0 to 3 comma 2. And so everything moves right 3 and 2 units up. So then we have a new graph like this. Okay, if you know the translation, if you know the rules of transformation, it's really easy to shift your graphs and compare your complicated function from your parent function. Now it's not too complicated anymore. So your vertical asymptotes also move with their graph, okay? So your domain and range will be a little bit different now. Instead of zeros, now your x cannot be 3 and y cannot be 2, okay? So your domain will be all real numbers except 3, and then range will be all real numbers except 2. Okay, so that's the change you have in the new function. Let's look at try number 5. Graph g of x is equal to 1 over x plus 2 minus 4. What are the equations of the asymptotes? What are the domain and range? So looking back to our translation, rule of transformation, please pause the video and see if you can graph it by yourself and figure this out. Come back when you're ready for answers. Okay, are you ready? Yeah, so looking at our graph, can you figure out h and k? H is, your horizontal translation is -2, which means move left 2 units. And then k is equal to -4, which means move down 4 units. So from our parent function here, 1 comma 1 and -1 comma -1, and then we had the asymptote at 0, x equals 0 and y equals 0. We're going to move our graph horizontally to the left 2 units, and then vertically down 4 units. And so that would be our origin. And that should be in your mind because our graph does not include this point. But that is your asymptote where your horizontal and vertical asymptote would meet. Okay. And then your graph just moves from 1 comma 1. We move 2 units to the left and then 4 units down. So now we have -1 comma -3. And then from -1 comma -1, we moved 2 units left. So that's -3. And then 4 units down, -5. So that is -3 comma -5. And then we have a graph that should be a really nice curve, but then yeah, it should look like this, which approach 0, which approach the asymptotes here. And your asymptotes, your new asymptotes are when y is equal to -4 and x is equal to -2. And you can already see the relationship between hk and your new asymptotes, right? They're basically equal to your new asymptotes. So your h and k will tell you your asymptotes as well. Yeah, so now that we have graphed it, let's write the vertical asymptote, domain and range in words. So the vertical asymptote is x equals -2, and the horizontal asymptote is y equals -4. Domain is the set of all real numbers except -2. And the range is the set of all real numbers except -4. Okay, so now we know how to graph all the different kinds of reciprocal functions as well. Well, we haven't really touched on other transformations, we just know the translation, but looking at other rules of transformation, you should be able to apply them too, right? Yeah, but don't worry too much about it right now. So let's summarize our concept. Inverse variation and the reciprocal function were the key ideas that we have looked at in this lesson. So remember that inverse variation have two variables where the relationship are inversely related. So they're not proportional. They're not directly proportional. They are inversely proportional. So y is equal to k over x would be the equation that could explain your relationship, and this also maps a reciprocal function. So inverse variation, reciprocal function are in the same. They follow the same idea. Reciprocal function models the inverse variation, y equals 1 over x. And remember that you can use the rule of translation to graph reciprocal functions that are more complicated than your original parent function. Alright, so that was lesson 4-1, inverse variation and the reciprocal function. We'll continue with the next lesson in the next video. Bye!